Okay, so 9-3, day 2. Yes.
Are those the same thing?
Yes.
So why is one like that?
Okay, I'm explaining why. Okay, so we're doing finite. Finite means it stops, yes? Okay, we couldn't find the infinite of an arithmetic because it went forever. You add and subtract forever. You can find the infinite sum of a geometric if certain conditions apply. So not always, and we'll go over that. But right now we're going to do finite. Okay, so what the boxed equation says, it says S sub n. If it has an n, it means finite. From the sum from 1 to n of the definition. This is just the summation notation, right, in that little box. The actual formula is a sub n times 1 minus r to the n over 1 minus r. So that's why the sum is there. I would write it personally, I would write the sum from I equals 1 to n of a sub 1 r to the I minus 1, that should be an n, equals a sub 1 minus r to the n over 1 minus r.
That's what that is.
Right, but in this order, it makes more sense to my brain
What's the different word?
because you would see this on the paper, and then you would have to know to do this. Does that make sense? You wouldn't see the S sub n and then that and then do the formula. The whole point is the formula is a sub 1 minus r to the n over 1 minus r. Now, on your test, you will have all 5 formulas for this section, but I'm not going to name them. They're there, and you have to name them. So then you can use them. Does that make sense? So for this formula, you would have the finite sum of a geometric sequence. Or you'd have to have finite, sum, and geometric in some order. Does that make sense? Sum of a finite geometric sequence.
Like a question is going to be named.
Yes.
Yep.
It will be like, it will have a, well, no, that's to your benefit because you just need to be able to identify them. Then you'll have them to use on the rest of your test.
Yeah, I got to remember the names.
Okay, okay, why do I know this is geometric?
Because of the R.
Because of the R. How do I know it's a finite sum?
The end of the n.
That's S sub n. So it's a finite sum of a geometric. The finite sum of an arithmetic was what? Guys remember?
Huh?
No.
N over 2, a sub 1 plus a sub n. If you know this is geometric, then this one has to be what? Arithmetic. And why do I know they're both finite sums? Because of the S sub n. If I have a sub n, a sub 1 plus n minus 1d, and a sub n equals a sub 1 r to the n minus 1, you can't tell me the definition of a geometric and arithmetic apart. Which one's arithmetic?
Not all.
The one with not r, the one with what? D. So it's an arithmetic definition, and this is the geometric definition. You can name these. They're not that hard. Look at your parts. These are definitions, yes? We know geometric has a ratio. We know arithmetic has a difference. These are finite sum because it says f of n, S of n. And then we know that's geometric because of the R. So if this is geometric, this one has to be arithmetic. And the last one you'll get is S. Well, these are finite sums because they stop at where? N. Is this one going to stop anywhere? No. So it's like when you break down the formula, it seems like a lot, but when all you have to do is name them, is it that hard to name them? Positive thoughts, Alex. Positive thoughts. Okay, so let's use it. So how do I get a sub 1? I plug in the what? We went through this with arithmetic. I plug in the 1. Okay? N on these is how many things you're adding. So if you start at 1, it's easy. But if you don't start at 1, you subtract and add 1 back in. Remember doing that? Okay, so S sub what? How many things are we adding? 1 to 12.
12, isn't it?
12. When it starts at 1,
Nobody was
it's...
saying anything.
I thought you said 13.
Yeah, and then nobody was saying anything.
Thank you. Thank you for putting yourself out there. Equals.
4.
Because you plug in 1, and 1 minus 1 is 0. Anything to the 0 is 1, and 1 times 4 is 4. 1 minus, what's R?
0.3.
Okay. To the n, what's n? We already found it. 12 over
1 minus 0.3.
Okay, without a calculator, there's not a whole lot you can do here, yes? I don't think you want to take 3 to the 12th. I wouldn't expect you to take 3 to the 12th. Maybe 2 to the 12th, but maybe not 3 to the 12th. 1 minus 0.3 would be 0.7, wouldn't it?
Yeah.
I might work with that a little bit, which would be 0.7, which would be 7/10. So we should multiply by the reciprocal, correct? I would rather multiply by 10/7 than divide by 0.7, wouldn't you? Because we've got this 4.
Yes.
So we're going to do 10 over 7. So S sub 12 equals 40 over 7 times 1 minus 0.3 to the 12th. Okay, on your test, without a calculator, that is your answer. With your calculator, you're going to put it all in at one time and get an answer. Is it that? How is that equation to use? Is it pretty straightforward?
Sure.
What's n?
12.
No, but what is n? Like, in general, what is n? Right, the number of things you're adding. What is a sub 1?
First one.
The first one. How do you get the first one with the definition and summation notation? What did we plug in to get to the first term?
Everything
We plugged in the lower limit. What's R?
else. If like the amount you add to get to the next number or minus to get to the next number.
Or geometric. It's the ratio. R is ratio. If you don't know, write these down. R is the common ratio. How am I going to know the common ratio? By looking at this definition every time. Where's the ratio going to be every single time on these? In the parentheses or the base of the exponent, yes? Because it wouldn't have parentheses if it was 0.3 to the I, would it? No. Okay, so it's the base of the exponent. What is n? N is the number of things we're adding.
Why is that one different than the first one?
Yeah, what is different about this one and that one?
There's no -1.
There's no -1. So this would be how, like, we would write our definitions, right? Because we said we're not going to have that -1 on there. So let's see what happens. Okay, so S sub what again?
12.
12, because 1 to 12. 1 to 12 is 12. Okay, equals a sub 1. We find a sub 1 by plugging in the lower limit. So if I plug in the lower limit, I get 0.3. So 0.3 times 4 is, so 1.2. Now, is anything else going to change over here? No. So is this going to change my amount? Yeah, because, well, now I've got 0.7. So 1.2 over 0.7 would be 12 over 7. Right? Are these going to have different sums? Put them in your calculator and see what you get. And when you put the 40 over 7, make sure you put that in parentheses. Alex. What did I just hear?
Nothing.
I think I did. And you'll have to look what the online book wants you to put it to the nearest whatever. Because I'm not
Usually
sure.
3.
Is it 3? So did you get 5.71 and 1.71?
Yeah.
I thought it was weird because it's 5.71428 and 1.71428. To me, that's weird that they're exactly the same after the decimal.
Probably because
Probably.
at point 3 as well.
Mm-hmm. Did you not get that, Alex?
No, I just wrote one more decimal.
Oh, okay. I just wrote that many. Questions?
No.
It's pretty simple.
It is pretty simple. Okay, use summation notation to write the sum. So summation notation has a sigma. So we have sigma, we have the equation, and we have our lower limit. I don't know what variable you guys are going to want to use. And we have our upper limit. So that we have to find the equation. Yes? Okay, so am I adding or multiplying to get from 9 to 18 to 36?
So times 2.
It's times 2. Yes?
Mm-hmm.
Okay.
That'll be all right.
Yep. So R is 2. So I have A sub n equals 9 times 2 to the n minus 1. So that minus 1 divides by 2. We went over this yesterday. So A sub n is going to be 9 over 2 to the n.
Why is the minus 1 circled?
Because the minus 1 makes it 9 times 2 to the n times 2 to the negative 1, which would be divided by 2.
Oh, yeah, leave it at this.
Hmm?
So leave it at this one.
Yep. Okay, so once I have my definition, I put it just in front of a what?
Sigma.
A sigma. So I have 9 halves, 2 to the n. And evidently, I have n as my thing. So n equals 1. Because when we write them, we're always going to start at 1, right? To what? Oh, I don't know what this is, do you? What term that is? Can I figure it out by setting our equation equal to it? Yep. Because I have to figure out what that upper limit is, don't I? So I probably need to multiply over by 2/9. And 1 plus 1 plus 5 plus 2 is 9, so that means 9 goes into it, doesn't it? So 9 goes into 11 how many times?
Once.
Once, with 2 left over. 9 goes into 25 how many times? Twice.
No, yeah, twice.
With 7 left over. And 9 goes into 72. How many times?
8.
8. And then times 2. So 16, 5, 2. So 256 terms. If I wrote all of this out, this dot, dot, dot represents 252 terms. Okay? So now we know why they're not all written out, correct? Okay, so it says use summation notation to write a sum. So did I do that? It didn't say to find it, it said to write it. If it said to find it, then I would throw it in the formula we just did. So it would be S sub 256 equals A sub 1. We can plug in 1, but we also had it over here. But 1 would make it 2, and the 2's would reduce, so I get 9. 1 minus, what's your R? 2 to the 256th over 1 minus R. So then we reduce it just to 9 times 1 minus 2 to the 256th. And we would be done. So the big thing about this is I had to figure out what? N. And how did I figure out N?
Being negative, not on it.
No.
It's a negative.
Setting that equation equal to the last one.
Oh, that you're right. Thank you. But why that can't be a negative?
9. That's 1 minus.
Oh, yes, it has to be a negative because this, the numerator, this right here is going to be a negative, right?
1.
This right here is going to be a negative. So then it has to be a negative. Yes. Sorry, Alex, you were right. Okay, so sometimes you're going to have to figure out that upper limit. Yes. And you used our definition to do it, didn't we? Okay, so let's do it again. I got to erase. You guys should have it written down. Okay, so R is going to be what?
Negative, divided by -5. So,
Negative 1/5?
yeah.
Okay. So yes, it is divided by -5, but we just put it as a multiply by negative 1/5. Okay, so oops. A sub n equals negative, nope, not negative. How about a sub 1 first? So 15 times negative 1/5 to the n, and I'm just going to put negative 1/5 to the negative 1. Because that's the n minus 1, right? What does that negative 1 exponent do? It divides it, so it reciprocates it. So it would be 15 times negative 5. So a sub n is going to be negative 75. If I could multiply. Negative 1/5 to the n. So all I do to that is put it in front of a what?
Sigma.
A sigma. You guys want to use x? You want to use n? What do you want to use?
I've been using it.
X. Okay, so x equals 1. So if you have been using x, you need to make sure when you're writing your definition that n becomes a what? X. You can't have an x and an n. That has to match. Okay, so we need to figure out our upper limit. So how do we figure out our upper limit?
Set it equal to the last.
Set it equal to the definition. So we have negative 3 over 625. So times it by negative 1/75. Okay, so negative and negative is a positive, right? 3 is 25, right? Okay, we know from our exponential unit that we're going to have powers of what? 5?
Is that a sub 1?
No, it's
What you
always
just did?
15.
A sub 1 is 15. We're trying to figure out our upper limit.
And
N.
You said it equal to.
Right, we set it equal to this. Because we're trying to figure that out. Okay, so we know from our exponential unit that we're going to have to be looking for powers of 5, correct? Yes? So I am not multiplying these out. 25 is 5 squared, correct? Okay, 625 is 25 squared. So that means it's 5 to the what? 4th.
so then it'd be
So I have negative 1 over 5 to the n equals 1 over 5 to the 6th. Does this make sense? So, what's n? 6? Now, people have a hard time with this because this is a negative and this is not a negative. Well, when I take negative 1 over 5 to the 6th, is it going to be negative any longer?
no.
No. So what term is this?
6.
6. So to do the S sub, so S sub 6 equals A sub 1, which is 15. And I could plug in 1 and I'd still get 15. 1 minus R, so negative 1 over 5
So do
to the
1/5.
6th. What?
So wouldn't it be plus 1/5?
Well, no, it's not going to be plus 1/5, and I'll tell you in a second why. Minus 1 over negative 1/5. Okay, the numerator is not, because I'm going to have to take my 6th power first, and my answer is going to be a positive, and then I still have a negative. So that numerator is going to stay. I could rewrite it as 1 minus 1/5 to the 6th, but it's still going to be a minus. Now the denominator is to the first power, so 2 negatives make it a what? Positive. So that's going to be 6/5. And multiplying by the reciprocal would be 5/6. So 5 is 75 over 6. So S sub 6 is 75 over 6 times 1 minus 1/5 to the 6th. If you're not sure about like this whole thing, getting rid of that, don't. Do you understand me?
Get rid of what?
This negative right here, we didn't bring it down because we said to the 6th would be positive. Correct? If you are not sure, don't do it. Does everyone hear me? Don't do it. Now, I will have people say, well, I can figure out 5 to the 6th. Well, yeah, you can, because it's 25 times 625. It's right up there. You could do it if you'd like, but I'm not going to make you. Now, if it's 2 to the 5th, am I going to make you? Yes, that's 32. You should already know that one. Questions on those? Okay, so I think we're just going to keep going.
No, it's fake.
Well, let's just write this down, I guess. And then we can stop and we can explain it tomorrow since I already started. Okay, an infinite geometric sequence. We can find the infinite sum of a geometric sequence only if, what does this say right here?
R is less than 1.
The absolute value of R is less than 1. Now I say absolute value of R because we just had negative 1/5, didn't we? Yes? So we don't do the negative, we do just the 1/5. Only. Now, the reason for that is when I'm multiplying by 5, is my number ever going to reach an end? No. But if I take 7 and I times it by 1/5, and I take that answer and I times it by 1/5, and I take it and times it by 1/5. And so I'm going to have 1/5 to the n. Yes? If I have 7 divided by a huge number, what is that basically? Well, the bottom's going to be infinitely large. But if I take 7 divided by an infinitely large number, because a fraction is dividing something up, yes? Mm-hmm. So if I have one piece of chocolate, and I say I want one Hershey's chocolate bar, and I want to divide it between us 5. That's pretty easy, right? I think we each get 3 squares. Okay? But what if I wanted to include Mr. Jurgen's room? So it's going to get, he's got like 20 kids in there, 25. So that's going to be really small, right? What if I say I want to divide it between the whole school?
That's going to be very small.
It's going to be very small. What if I decided to divide it between the whole town?
It's very, very small.
It is very small. It's close to what? 0. Is it so close to 0 I couldn't even really tell the difference?
Yeah.
Yes. So that is why we can find the infinite sum when R is less than 1. When the absolute value is less than 1. Is because I'm multiplying by a number that's so close to 0, I can't tell the difference. So I would be adding a number so close to 0, it wouldn't really make a difference. Does that make sense? So how that would work is, if I have this equation, this should look familiar. We just did it, yes? Yes? Okay. And I told you this would eventually become 0. Well, what's 1 minus 0? 1. So my formula, it breaks down to a sub 1 because it was 1. Oops, go back. This thing is like so jumpy. Okay. So if this becomes just 1, yes? Well, couldn't I just take a sub 1 times 1?
Mm-hmm.
Yes? And I would get this formula right here. And the way they wrote it is weird. I would write it. Why is it doing this?
So it's basically...
So it's this. Oh. The sum from I equals, and they have 0, but it doesn't matter, to infinity. That would make it infinite, right? Or, what at the end? ... of a sub 1 r to the n minus 1 equals s. There's no sub n because it's the infinite. A sub 1 over 1 minus r.
It says R to the I instead of R to the...
Because they have what?
Oh.
They started at where?
But you put 0.
Oh, sorry. I'll put 1. Sorry.
So if it equals 1, it's n minus, but if it's not 1, it's just...
0, unless we've written it. Not always. It depends. Don't make those. It doesn't matter. Yeah, don't make those links. So, how would I know if I'm labeling this formula what it is? What is it missing? It's missing the n, yes?
Yeah.
So that makes it infinite.
Mm-hmm.
Okay? And it has an r, so that makes it geometric. So we have the sum of the infinite geometric. So, honestly, I'm just going to keep going because is this going to be any different than what you just did? No. What do we have to decide if what applies? If that applies.
Absolute value of R is less than 1.
The absolute value of R is less than 1, you can do it. If I ask you to do it and R is 6, and I ask you for the sum, I say the sum. That means everything, yes? And my list went whatever, whatever, whatever. Oh my gosh. Where did it go? The list was like whatever, 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 plus dot, dot, dot. Okay, that's infinite, yes? And I said find the sum. And R is 6. You would say undefined. Absolute value of 6 is greater than 1. And that's your answer.
Okay.
Do you think there's going to be at least one of those on the test?
Probably.
Yes. Everyone have that equation down?
No.
No? Okay. I think we have one slide, too, maybe. Okay. Okay, so how do I know it says find each sum. So how do I know both of these are infinite?
That one has the infinite sign on it, and that one has dot.
Right. One has the infinite sign at the upper limit and one has dot, dot, dot. So can I do it, first of all? Can I do A?
Yeah.
Yes, because 0.6 is less than 1. So the sum of A sub 1 is found by putting in the lower limit. So I plug in a 0. So 0.6 to the 0 is 1. Anything to the 0 is 1.
Okay.
Times 4 is 4.
Hold on. What? So you put 0 in for n?
Yep, just like we've been doing. And then 1 minus R. What's R? 0.6. So I have 4 over 0.4. Can I leave it as 4 over 0.4? In unison, you should all be saying no. You can't leave a decimal in a fraction.
Oh, is that what you said?
Yes.
Most of the time when I read the question, it's always a yes.
So I got to move the decimal once. So move it once. So I get 40 over 4, which is what? 10. So the sum of that equals 10. Okay, 3 plus 0.3 plus 0.003 plus 0.003 plus 0.0003, right? Okay, so we got to figure out what R is. Do you remember how to figure out R?
1/10.
Yes.
0.3 divided by 3.
So it's 3 over 30, so it's 1/10. So is 1/10 less than 1?
Yes.
Yes, so we're good. So S equals, A sub 1, 3 over 1 minus, do you want to put 0.1 for now? Or do you want to put 1/10? What? 0.1. Okay, so that's 3 over 0.9. So move the decimal once and add a 0. So 10 over 3. Right? Yep. So which ones do you prefer to do?
Not these. These ones. I don't like these ones.
I like these ones.
I'm jumping on these. I feel like I always do them too quick.
Yes.
We good? Got one more. Oh, nope. I don't got no more. So now